All right, Unit 5 Radical Functions, 10-1, Day 2. Today we're focusing in on cubics. Yesterday we did the quadratics. Remember, we're finding an inverse. We're going to switch our x and y values. So we're going to find the inverse of each cubic function, confirm the inverse relation using compositions, and we're going to graph the function and its inverse. I apologize, my pen looks like it's fading a little. It's not. It's brand new. It's just got to warm up a little bit. So our first function is f of x equals x cubed minus 9. So the first thing we want to do is find the inverse. Notice here in the directions, it doesn't ask us to restrict the domain. That's because with cubic functions, we do not need to restrict the domain. So it's kind of a nice little break. We don't have to restrict our domain. So we want to switch the x and the y, which means we actually have to write the f of x as the y. And then we're going to switch them. So x equals y cubed minus 9. Add your 9 to both sides. So x plus 9 equals y cubed. Cube root both sides. This little 3 has to be up here in the index to show that you're cube rooting. It is the way that everybody denotes that. So we all know it's a cube root, not a square root. And then we have the cube root of x plus 9 equals y to the negative 1. Putting it back in correct format, because it did give it to us as f of x. Cubed root of x plus 9. So there is our inverse function. Now, I need to use compositions to make sure that they really do match. So I'm going to take this and plug it in for the x here. So I have f of x equals the cubed root of x plus 9 cubed minus 9. Well, when you cube a cube root, they just kind of cancel each other out. And we get x plus 9 minus 9, which means we end up with just x. That means that we actually had the right inverse, and it works. Now, we want to actually graph the functions, the inverse and the regular. So I'm going to graph the function itself. I'm going to graph it in pink. If I plug in 0 for x, the y value is negative 9, and I'm just quickly doing a little table in my head. If I plug in 1 cubed is negative 8. If I plug in negative 1 cubed is negative 1 minus 9 is negative 10. So my graph is kind of doing this little bit where it makes that transition, that turning point right there on the axes. Now, I want to graph my inverse function, and again, I'm going to do a little table of values in my head, and I don't have to worry about negatives because I can take the cube root of negatives. If I plug in negative 9, that's 7, there'd be 8, 9, it'd be here. Negative 9 plus 9 is 0, so the cube root of 0 is going to be 0. If I plugged in negative 8 for x, negative 8 plus 9 is positive 1, cubed root of positive 1 is positive 1. If I plugged in negative 10 plus 9 is negative 1, cubed root of negative 1 is negative 1. And so I'm going to get something that looks like this. Sorry, I just made this go the wrong way. Like this. And so this over here in the pink, and they're kind of close together. But if you were to fold them up, they would actually kind of look like they laid on top of each other. And this is the graph of the inverse and the function. You want to make sure that you label them. This is the inverse. This one would be the function. And we're good. So on number 2, our next example, it's a little bit easier. 9 is kind of a bigger number to graph, but it's okay. We have to find the inverse first, use the compositions, and then we're going to do some graphing. So let's start by finding our inverse. That means we're going to rewrite f of x as y, and we're going to switch the x and the y. Solve for y. So I'm going to divide out the 2, and I'm going to rewrite that as 1/2 x. And then we're going to cube root. So we get, this is the inverse, is the cubed root of 1/2 x. And I'm going to put it back back into the format they gave it to me. F the negative 1 of x equals the cubed root of 1/2 x. Now, we do need to check the composition. So we're going to plug this into the x up here. So we get f of x equals 2. And instead of x, we're going to put in the cubed root of 1/2 x, and it's cubed. Those two values, they just cancel. So we get 2 times 1/2 x. That just leaves us with x, which tells us that the inverse is correct. We're good to go. Now we need to do some graphing. So we're going to graph the original function in pink. If I plug in 0, why do I use 0 and 1? They're just easy numbers. 0 cubed is 0 times 2 is still 0. If I plug in 1 for x, 1 cubed is 1 times 2 is 2. If I plug in negative 1, negative 1 cubed is negative 1 times 2 is negative 2. And I get something that looks like this. And that is my function. And I know on the other graph you couldn't see it as well because it was kind of at the bottom. Now, and they were closer together, graphing the inverse. Right here. I'm going to plug in values for x. I'm going to start with 0 because 0 is very easy to work with. So half of 0 is 0. Cube root of 0 is 0. Now, I don't want to use 1 because I don't want to take the cube root of 1/2. But if I put in 2, 1/2 of 2 is 1. Cubed root of 1 is 1. So when I plugged in 2, I got 1. If I plug in negative 2, 1/2 of negative 2 is negative 1. The cubed root of negative 1 is negative 1. And this is going to go up like so. And this is my inverse function. So they're very similar to each other, and they're going kind of in snake positions. The inverse should always go left to right, and the original on a cube should go up and down. Now, we've got one more example to look at, and it is actually looking at your word problem. So it's the function a of r equals 4/3 pi r cubed. Gives the surface area A of a sphere with a radius r. Find the inverse function r of a to find the radius of a sphere with surface A. So what we're going to really do here is, this is the equation. The area is equal to 4/3 pi, whoops, I wrote 4/4, pi r cubed. Now, in order to solve it and write r of a, I just need to take my equation. I'm just going to solve it for r. So I'm going to multiply both sides by 3/4. So I get 3 times a divided by 4 equals pi r cubed. I'm going to multiply both sides by 1 over pi. Because I'm trying to consistently, instead of dividing because I have a fraction over here, I'm going to multiply by the reciprocal. That gives me 3a over 4 pi equals r cubed. Now, to get rid of the cube, we're going to cube root both sides. That means r equals the cubed root of 3 times a divided by 4 pi. Now, this is our function. This is the equation, and it asks us to find the radius with the surface area. So putting it back into proper format, it says to find r of a. So we would want to just rewrite this r of a. That means radius is given in terms of the area. And there we go. That would be the equation. It didn't ask us to find anything specific. So we just want to make sure we put it back into the format it asked for. And we're done.